Good afternoon, everyone. I'm here to present our work, LAMBRETTA, Learning to Rank for Twitter Soft Moderation. So social media platforms, they have increasingly adopted soft moderation interventions as a way to inform users about the type of content they are consuming in the platforms. These warning labels and soft moderation interventions, they can guide user towards piece of debunking articles when the news articles they are sharing is false, or they can guide user to be careful of the type of information they are consuming in the platform, especially in the case of elections, pandemic, and the initial reports of social media audits. They have found that warning levels can be pretty effective on decreasing the dissemination of potentially misleading content by as close to 15%. And you can see examples of different social media platforms such as Twitter, Facebook, and TikTok applying soft moderation interventions in the case of COVID-19, election, and climate change related information. However, what we find is there are some limitations on how these social media platforms have applied these soft moderation interventions. So as an example, you can see on the left, there is a tweet that talks about dead people returning absentee ballot in Michigan, which is obviously not possible, and this piece of news has been thoroughly debunked to be false. Twitter, it did apply warning level on the tweet at the left, but there are two tweets on the right that are exactly talking about the same claim using more or less same detail, but there is no warning levels on the tweets on the right. And this is only part of the overall inconsistency that we find in Twitter with regards to applying warning levels. And eventually we empirically demonstrate that Twitter moderated only close to 5% of the misleading information content in the platform with related to the 2020 election. So our goal here is to improve this moderation landscape on social media platforms by proposing a tool which we call LAMBRETTA. The multiple motivation of designing this system is we want our system to be claim specific rather than topic specific. So what happens when the moderation happens on a topic specific level is every other post that talks about a particular broad topic such as election or COVID, they might get flagged. As you can see on the example on the right, there is a tweet. It includes some term about 5G and oxygen, and it is receiving warning label, but which it should not be. And this can lead to something called as alert fatigue, where users are just seeing too many warning labels in the platform, and the efficiency of warning levels can decrease with regards to their purpose. And another study, it also found that close to 37% of warning levels that appeared on TikTok, they were mostly false positives. So that's why we want a system that is that follows claim-driven approach to moderation. And eventually the goal of our system is to assist platform moderators to scale their moderation efforts by identifying claims in a tweet and identifying similar tweets that are discussing a claim. That's why we take already moderated sample of tweets from the platform, and we try to find similar set of tweets. This is the system diagram. There are three different components. First, we build claims from tweets, then we identify the keywords from the claims, and then we identify similar tweets that are candidates for moderation. For the data set, as I discussed before, we initialize our system with already moderated tweets that we know are for sure contain misleading information. And in our case, these tweets are related to the 2020 US election. There are close to 2,200 tweets that have this moderation status. And for validating our method, we use a larger set of tweets from the data set called voter fraud. And it is noted that this data set not only contains potentially misleading set of tweets, but also benign set of tweets related to election. And the evaluation and data set period, it coincides with the 2020 election period. So at this point, we have these 2,200 tweets that were moderated by Twitter and that contain misleading information. So the next step is, since the system design motivation is claim specific, we want to extract claim spans from these tweets. So what you are seeing on the board, out of the overall tweet, these are the spans of the tweet that actually contain a claim. And naturally, people tweets, they will have nuisances or noise that we want to get rid of and only focus on the claims. And also there will be examples, there will be scenarios in which a tweet doesn't present a claim at all from a more subjective point of view, and we want to filter those out as well. So for extracting claims, we use an approach from linguistic to derive these unit of claims called propositions. Propositions, they are potential candidates for containing a claim, and for that we use a tool from NLP called Open Information Extractor. So using this tool, we can gather a set of propositions, and the next step is not all propositions naturally contain a claim, so we need to filter out claims from these propositions, and for that we use another tool called Claim Spotter. What it does is basically, given a piece of text, it gives a likelihood of the particular piece of text containing a claim. We had to experimentally filter out what makes these propositions a claim and separate out the claims from our data set. So at this point, we have reduced the tweets into these pieces of claims that can be traced on the wild. So for that, the next natural step that we applied was we tested out some keyword extraction-based method to extract keywords from the claims, but we found that there are limitations contained in these methods, such as they are missing key entities related to the claim. They have either very high precision and low recall, or either they have very low recall and high precision. So we had to reframe the keyword extraction problem. So we took this approach of identifying keyword, that most of these state-of-the-art algorithms, they just look at the body of the claim and try to extract keyword from it. But we looked at not only the claim body, but also the semantic similarity between the tweets that discuss the claim and the actual claim itself to derive the keyword extraction process. So we use a framework from machine learning called learning to rank, which basically, given a query and a set of results, you would want, the system tries to rank the best set of results. But in our case, we are trying to rank the best set of keywords that describe a claim. And this is the problem formulation for the learning to rank tasks. We have these claims extracted from the claim extractor component, and every possible n-gram that comes from the body, they are candidates for being the optimal set of query, but we don't know which of these is actually the best query to describe a claim. And for that, we query the bigger set of tweets to extract features such as number of matching tweets, semantic similarity between the tweets that are returned by a query, and semantic similarity between the claim and the result set. So the idea is the set of tweets that are discussing the same claim, they will be pretty similar to each other than everything else, and also they will be pretty similar to the claim, and we can leverage these features to create this ranking model that will rank the optimal set of keywords higher than the other choices for keywords. And we experimented with multiple algorithms from the learning to rank paradigm. We found this random forest method with LAMBRETTA. It gives the best performance, and we use this final ranking model to identify keywords for the 900 different claims that we extracted from our 2,200 set of tweets. And using these keywords, we identified more than 100,000 tweets from the voter fraud dataset that are discussing the claims that Twitter already moderated, and thus we can assume that these are candidates for moderation by that virtue. Before validating, I'll quickly go over how our system performed in comparison to other keyword extraction method. So we compared both semantic similarity-based method as well as keyword extraction-based method to compare our system. it outperforms all the other methods. And at the same time, one key piece is because we are envisioning this system to be part of the human moderation pipeline, we would want as less false positives as possible. And our system, it achieves a high F1 score by reducing the potential moderation load, which is the false positives that the human moderators might have to go through, by close to 5.33 times than the other best performing method. Now we validate the false positive of our system, and for that we manually sample 1,500 tweets and check if the identified tweet is basically discussing the same claim that it was used to retrieve with. And we found that close to 4% of the tweets were identified as false positives. And while doing the manual analysis, we found different categories of tweets, and Twitter even moderated the tweets that are debunking the false piece of information. So there seems to be a room for improvement on that regards as well. On the false negative of our system, it was 18.81% compared to the second best performing method, EC, which is an acronym for yet another keyword extraction. It is significantly better. And now these 100,000 tweets that we have identified from our system that are candidates for moderation, we checked for moderation metadata from Twitter. Did they actually apply the warning levels? And Twitter, it applied the warning levels only to 4.3% of the tweets. So we see that there is deficiency on whatever system Twitter has on applying soft moderation levels. We checked for different signals or different heuristics to see if the warning levels and their application is being driven by particular indicators, such as lexical similarity between the tweets, or as you can see in the example, the two pair of tweets that are pretty lexically similar. One of them is moderated, the other is not. And then we also check at URL and also the popularity of the accounts that tweeted the tweet to see if Twitter is prioritizing certain indicators, but that didn't seem to be the case. We have more detail of all these additional analysis in our paper, but our takeaway was the picture of content moderation from Twitter's point of view was really puzzling, and that led us to ask, do they even have a particular system in play to apply soft moderation on misleading information at their platform. So we present our system, LAMBRETTA, that is designed to help platform moderators scale their moderation efforts. And in this case, we demonstrated that we can scale it up to 20 times. And we demonstrated our method in the context of 2020 US elections, but it can be extended for other type of misleading information. There are some limitations to our work. That is, it is an inherently reactive system because we have these initial set of tweets that we already know are containing misleading information, but our system, the goal is to amplify and identify more candidate tweets. And our evaluation, it was limited on the US presidential election, and the learning to rank setup that the system relies on, it is supervised learning setup, but currently we are exploring other weakly supervised models to improve upon that part as well. These are the references, and yeah.
And we have a minute or two for questions if anybody has them from the floor. Okay, sounds like people are ready for lunch. So thanks to all the speakers, and thanks everybody for coming to this session.